All right, in this video, I'll be going over some miscellaneous topics where we're going to be working with whole numbers. All right, so let's go ahead and get started. So first of all, we're going to talk about area versus perimeter. It's important that you're comfortable with both. So first of all, if we have a rectangle, and it's 4 centimeters by 6 centimeters, what if I ask you to find the perimeter? Or if I ask you to find the area, would you be able to do that? So if you know how to do that, you can skip this and move on to the next page. But I'm going to go ahead and do the problem now. So if you wanted to try it, you should stop the video and then you can check your answer. All right, so to find perimeter, when I think of perimeter, it's first of all, it's the distance around the outside of the figure. I think in terms of, I call it the fence. Hold on a second. Think of the word fence, because it's like measuring the distance of the fence along the outside of the figure. All right, but we do have a formula. Now you could notice you have 6 centimeters on each side and 4 centimeters on each side. And so you can see there's 2 widths and 2 lengths, and you can see that in the formula, perimeter equals 2 times the width plus 2 times the length, 2w plus 2l. So all we're going to do is plug in the numbers. So 2 times 4 plus 2 times 6, that's going to be 8 plus 12, and you get 20. Now the question is, 20 what? Well, if you had a measuring stick and you went around the figure, you would just be adding these numbers basically, and so it's just going to be centimeters. All right, so it's just a distance along that outer fence. All right, let's look at area. So for area, we have a formula. It's A equals L times W, or length times width. So here we multiply 6 times 4 and we get 24. But again, the question is, how do we do the units? So you should have put centimeters squared. So my question is, do you understand what that means? Well, area is basically the inside, we're measuring the inside space of this figure. And so really, if you think about it, 1 square inch or square centimeter would look like this. It's 1 by 1 centimeter. So 1 centimeter by 1 centimeter. And notice that's how many squares 24 would fit inside this figure. You could actually see it by doing this. And so this is why area is always square units. We're really counting the number of 1 by 1 squares that would fill the inside of a figure. And so that's why we say 24 square centimeters. All right, let's move on. So just remember, area, your units won't be squared. Perimeter, your units won't be squared. Area, it'll always be square units. All right, let's move on. Let's talk about the language of operations. What do I mean by operations? That's these guys: addition, subtraction, multiplication, and division. So there's words that we tend to use with these. So notice we have 4 problems here. Find the sum of 8 and 12. So in this case, sum means add. So you're adding 8 and 12, and of course that's 20. Number 2, by the way, when you add numbers, notice the order is not important. I could add 12 plus 8 and I'd still get 20. Let's move on to the quotient of 48 and 4. So we're going to divide 48 by 4. Well, hopefully you know your 12s. 48 divided by 4 is 12, or 4 times 12 is 48 if you're going in the opposite direction and you're multiplying. So here you do get 12. Number 3, the product of 80 and 20, we're going to multiply here. Now there's a shortcut when you have numbers that end in 0 like this. I can just multiply the 2 and the 8 and you get 16, and then just add 2 zeros to the right of that. So that would be 1600. On number 4, you're going to find the difference. The difference between two numbers you're going to subtract. So this is 100 minus 24. So think of it as a dollar minus 24 cents. Hopefully you can do that in your head. You get 76 cents, or 76 is our answer here. And I do want to mention on number 3 with the product, if I had 20 times 80, I would still get 1600, so the order doesn't matter. But notice with the difference, the order definitely matters. The 100 has to be written first, and then the 24, because certainly 24 minus 100 would give you a different answer. You'd get a negative number. All right, let's move on. Let's talk about division with 0. So here's two problems. Go ahead and see if you remember how to do these. All right, so 0 divided by 3, you should have gotten a 0. Wait a second, I need to go back. So this is 0. Let me change colors here. And on 3 divided by 0, you should have said that one is undefined. You can't do division by 0. So let's talk about why. We know if we had, for example, 6 divided by 2, that that's 3. We should be able to reverse the process and multiply. Notice 3 times 2 is 6. And so if you go back to A here, notice that 0 times 3 does equal 0. And so we can reverse that. You can see when you do multiplication that if 0 divided by 3 is 0, then 0 times 3 should equal 0, and it does. What if you were dividing 3 by 0 and you're like, well, I don't know, I think that should be 0. Well, then what you're saying, if you reverse it, is 0 times 0 is 3. Well, 0 doesn't work. In fact, is there any number that I can multiply times 0 and get 3? No. This is irreversible. It just is an indication that we cannot divide by 0. Division by 0 is undefined. If you do it on your calculator, it'll give you some kind of an error message. All right, let's move on. So finding the average for a set of numbers, that's something you should be able to do. So we have Marie, and she has test scores of 90, 72, 78, 66, 89, and 82 in her math course. So we want to find the average of her test scores. So go ahead and do that if you know how to do that. All right, so to find the average, we should add the numbers and divide by how many there are. In this case, there's 6. Now, you didn't have to write it out like I did, but normally I like to see at least one step, so maybe you can at least show me the 477 you get when you add those numbers divided by 6, and so when we do that, we get 79.5. So she's right on the borderline B, and if she's about to take a final, she's going to need to get a B on the final probably to get a B in the class. All right, let's move on to the next slide. We're going to talk about exponents. So if you have 3 to the 4th power, which is what we have here, can you write what that is equal to? All right, so you should have done something like this. What that means is I need to multiply 4 3s. And when you do that, you should get 81. Now, I think everybody knows we call the 4 an exponent, but the 3 is also very important in this problem as well. And you're going to see this number becomes very important, especially when we start dealing with negative numbers and some other things in algebra, other situations. So you should know that the 3 is the base. You may have forgotten that one. So I do want to point out on a calculator, you would put in the 3, then the caret symbol, and then a 4. All right, so let's go on to order of operations. So I'd like you to evaluate this problem here. All right, let's see how you did. So in the order of operations, multiplications and divisions always come before additions or subtractions. In fact, subtractions and additions are at the bottom of the priority list. And if we have a division and we have a multiplication, we do the one on the left first. So I hope you heard that clearly. We do not multiply before we divide. Those are equal priority. We do the one on the left first. So we actually divide here first. So it'll be 12 plus 4 times 4. So the next priority would be to multiply. And so we're going to get 12 plus 16, which is 28. Now I want to go through the priority or the order of operations. I know some people use PEMDAS, but I'm not a big fan of that because sometimes it gives you the impression that maybe multiplication comes before division or addition comes before subtraction, and that's not true. So in the order of operations, you always simplify anything in parentheses first. We use parentheses to make sure things are done in the right order, and whatever's in parentheses gets done first. So parentheses, I say, is king. And after that, you have exponents. You could also put square roots or radicals in there as well. And then additions and subtractions. And I'm sorry, I said boy, I'm not talking well here. So multiplication, division, and then additions and subtractions are last. So I like to get a little fancy here. I'm going to make parenthesis king. And I do want to point out that for operations equal in priority, like multiplication and division or addition and subtraction, we always work left to right. So hopefully that's a good reminder of order of operations for you. I'd like you to try these two problems. The other thing I would point out, this is something I always tell my students, is you should be able to do these step by step, but you should also have a calculator that you can use and you can check your answers with. On a test, you should never miss a problem like this because your calculator will do it. If you have a good calculator and you can put it in to the calculator just like it looks on paper, then you should never get a wrong answer, even if you're having a hard time doing it step by step and getting that answer. So go ahead and try those, and then I'll go ahead and put the solution up. All right, so let's see how you did. So first of all, we know parentheses is king, so we should be subtracting 5 from 7. And so we end up with 21 minus 3 times 2 squared. And then the next priority is exponents. So we're going to square the 2. Notice my base is just 2. And so we're going to end up with 21 minus 3 times 4. Of course, multiplication is next. Remember, addition and subtraction are always last. We get 21 minus 12, which is 9. All right, on number 3, the main thing to remember with fractions like this is you want to simplify the numerator and simplify the denominator, and then whatever you get, you divide or simplify. If it's a fraction that can be simplified, you do that. If it can be divided, you divide it. So in this case, we would get, well, first of all, in the numerator, we want to apply the exponent first. Now remember, this is 2 to the third power, 2 times 2 times 2. So we're going to get 5 times 8 here. And in the bottom, remember, we go left to right with things that are equal in priority. So we're going to end up with 7 plus 3 in the bottom in our denominator. So we're going to end up with 40 over 10, which is 4. Now, if you're in my class, you should have access to, when you're doing your homework at the very beginning, you should see a video on an introduction to the TI-30XS multi-view calculator. So that's there. You can also go on YouTube and look up Scott Smith and put in calculator, and that's another way you can get to the video that shows you how to put these into your calculator. All right, let's move on to the next slide. So I want to talk about algebraic expressions versus equations. Really, really important that you understand the difference. So if I said, what do we do with algebraic expressions? Think about what we do whenever we're given an algebraic expression. What are we going to be asked to do? And the other question I have for you is, what do we do with equations? And hopefully you remember that one. Usually on number one, people may or may not remember, but with equations, usually people do. All right, so what do we do with algebraic expressions? We either simplify them or we evaluate them. So let me show you what I mean. So for A here, we have simplify 3x plus 4x plus 2. Now the 3x and the 4x are what we call like terms because they both have one factor of x, one variable factor, exactly the same. They have to be exactly the same. Notice the 2 has no variable factor, so it's not a like term to the other two. So 3x and 4x, we add those together, we get 7x, and we'll get into that more later. Plus 2, and I can't do anything with those, anything more, because they're not like terms. So that's how we would simplify an algebraic expression. Now the other thing we sometimes do is we evaluate algebraic expressions. When I say evaluate, that means you should be able to give me a number for an answer. So the expression here is 4a squared, and if you tell me what a is, I should be able to tell you what this value is. So we're just going to plug in 3 for a, and we're going to use order of operations, so we'll square the 3 first. We're going to get 4 times 9, and of course that's 36. Now what do we do with equations? We solve them, of course. So here's a problem. Solve the equation 3x plus 1 equals 7. Why don't you see if you can do that? You might be able to just look at it and figure out what x needs to be. Basically, we're looking for a number that I can plug in for x, and it makes the equation true. All right, so you should have gotten 2. Notice that if you plug a 2 in here, if you plug a 2 in here, 3 times 2 is 6 plus 1, that does give you 7. So 2 is what we call the solution. Now I could give you a problem like B. Determine whether 2 is a solution of 3x minus 4 equals 2x plus 1. So why don't you see if you think that that's a solution or not? Well, how would we know? We would plug 2 in for x and see if it makes the equation true. Well, on the left side, we'd have 6 minus 4, that's 2. And on the right side, we'd have 4 plus 1, which is 5. And so notice those are not equal. This is a false statement. And so no, this is definitely not a solution. All right, let's move on to the next slide. And we're going to wrap things up with a little bit more dealing with the language of algebra, translating expressions. So let me go ahead and give you a table to help you. When you see these words, you should think addition, subtraction, multiplication, or division. So for addition, we have words like sum, add, plus, added to, increased by, more than, total. For subtraction, we have words like subtract, difference, minus, less than, decreased by. For multiplication, we have multiply, product, multiply times, twice, of. Like when you find 1/2 of 10, you could think of that as a multiplication problem, 1/2 times 10. Double and triple, that also indicates multiplication. And finally, for division, we have divide, quotient, divided by, shared equally among, divided into. Okay, so let's practice. So go ahead and try these 7. See if you can translate these into a variable expression. And then you can check your answers. All right, so let's see how you did. So when we total numbers, we add them up. So we have 2 plus x plus y. On number 2, the quotient of 7 and a number. Now with quotient, this is division. We got to make sure the order is correct. The first number is going to be in the numerator, and the second number is going to be in the denominator. So that's the quotient of 7 and x, or 7 and a number. We could have also written this as 7 divided by x. We tend to use fractions when we write division in algebra, which is where we're headed. 8 less than a number. You got to be careful with these. If I had a number minus 8, you would say x minus 8. Or if I had 8 minus a number, you would have 8 minus x. With less than, you got to be a little more careful. This should be x minus 8. Think about this. What's 8 less than 100? Well, that's 92. How did you get it? You started with the 100 and you subtracted off 8. So if you want 8 less than a number, you start with that number, here we're calling it x, and you subtract off 8. So be careful with less than. It's a common one that students get reversed. The next one is similar. A number subtracted from 31. So basically we have a number that's x that's going to be subtracted from 31. So we start with 31 and we subtract off x. The time t increased by 2. So we start with t and we increase it by 2. That means we're going to add. 3 less than twice a number. Well, if we want 3 less than twice a number, we start with twice a number. That's 2 times a number, 2x in this case. And we want 3 less than that, we'll subtract off 3. Okay, last one. The product of 6 and a number decreased by 5. So we're going to start with the product of 6 and a number, that's 6x. And we want that decreased by 5. And so that's 6x minus 5. All right, that's it for this video. No, that's the end.